Hi everyone, and welcome to Module 2C of my full Python course. If you have not enrolled already, please subscribe. Let's get started. So it should be a pretty quick one today, where we're going to talk about the idea of a set. Now, a set is logically a bunch of things, so it's going to be a container. So it's going to say, okay, here's my container. It's going to hold a bunch of things, except we're not going to have order, and we are not going to allow duplicates. So that is very different from a list, where we'd say, okay, the list of 1, 1, 2, 3. Well, that is the ordered list of 1, then 2, then 3. Common sense, right? Except I'm saying it like that for a reason. We have 1, 1, 2, 3, and we could ask, say, okay, what is the first thing? Well, that's the value of 1. What is, say, the third thing? Well, that is the value of 2. This idea makes no sense in a set because it's just a bunch of stuff in a container. You can think about it as a jar and shake it around. It's the same thing no matter what arrangement that they end up in. So to show this example, I will first show that you make a set normally like this with a list of values. So braces, similar to the dictionary, as in dictionaries use the braces, except we are not going to do a key value pair, so key comma value, or as I showed you before with a string, key value. We're not going to do that. It's just going to be separated values. So 1, 2, and 3 is a set. It's the set of 1, 2, 3, basically. Now, I can't ask what is the second thing in the list, or in the set, sorry. It's not subscriptable. It doesn't have order. And it doesn't have duplicates. So if I was to ask, what is the set of 1, 2, 3, 3? Well, that's not, it's saying build a set from this information. And so duplicate values do not belong in a set. What it says is, okay, put 1 in the set, that's fine. Put 2 in the set, yeah, that's fine. Put 3 in the set, that's fine. But then put 3, no, don't put the next 3 in the set. We have seen this already, do not put that in there. So that's the idea of a set, and they are useful for a couple different operations. I'm going to show a couple of them as well. So if we did have the set of 1, 2, 3, 3, and actually first I will show that you can also build a set from a list. We have the equivalent way of doing this is 1, 2, 3, 3, and that's often how you would end up building a set, is you already have a list of stuff, and you're turning it into its unique values into a set. So that's why I'm showing you this syntax. And now what you'd often do with a set, if we had, say, S1 is equal to the set of 1, 2, 3, and S2 is equal to the set of 4, 5, 6. And if I asked, what is the union, so I do S1 dot union of S2. Okay, so I say this set dot union S2. Well, you can see by example what that's doing. Picture a Venn diagram. If we had 2 circles, basically you had S1, what's in S1, and what's in S2. If there's no overlap, all it's going to do here is say, okay, bring me everything that's in S1 and bring me everything that's in S2, and put that into a single set. Now, if there was overlap, watch what happens. So overlap, I mean there's a element that's in A and B, or as I'm saying, in S1 and in S2. So 1, 2, 3, 4 with 4, 5, 6. Well, that's going to be the exact same thing because it's still saying a set cannot have duplicates. So if I'm bringing everything from S1 and everything S2 into a set, well, if there is overlap, then just get rid of the overlap because we don't want that in a set. Sometimes we might want to know what the overlap is. So I could ask S1 dot intersection S2. That brings me the overlap between S1 and S2. And if there is none, well, there is no overlap. And so that is going to bring the empty set. There's a couple other things you can do with sets. I'm not going to show most of them. The only one that I'm going to show now is the idea of checking whether something is in the set or not. Quite often you will find this problem of you have a set and you want to ask if something is in the set. Notice I said if, as in I want the answer in a true or false form. So is this thing in this set? So for example, 1 in, I will just replace this with S1 from above. So this should return true because 1 is in this set. And the opposite for in S1, it is not. Okay, so that's the main idea, and I will conclude by showing you that this idea of in is not just unique to sets, but it is also allowed in lists, although this is, you'll find later, slower than it is in a dictionary or set. They are implemented fairly similarly in Python. So is 4 in this list? No, it is not. But is 1 in this list? Yes, so you could do that with lists as well. Hi, sorry, one more thing you'd want to do with the set is often you would start from scratch and have an empty set, s is equal to nothing, and then you'd probably iterate over something else. So say for elem in some other list, and we'll just say 1, 2, 3, 3, and then yes, you could turn this whole thing into a set right away, except I'm saying often you would want to go through this thing, maybe do some if statements or something in this loop, and then add it to the set. So to do that, you would do whatever if statements, and then you'd write s.add, and then the element. So s.add elem, and there you go. Dict object has no element add. That is because, and I did this on purpose, is to show you that very commonly you're going to run into this error where you think that the set notation is these curly braces, and actually the only way it defines it to be a set is if you have an element in here without just an element, actually, because if you do key value, then that is a dictionary, and if you do nothing, then that is also a dictionary. So actually you always have to write set of bracket bracket or parentheses, whatever you want to call it. S is that set. Go through it, add the element to the set, and the S is only going to be the unique element because again it adds 1, that's fine, adds 2, that's fine, adds 3, that's fine, adds 3, no it doesn't, it says okay 3 is in there, and that is the set. Thank you for watching, I will see you in module 2D.